In this video we are going to study about multiplication principle and addition principle. If we check the difference between them, addition principle and multiplication principle, here we can understand from the first word. Let A be two actions that cannot both perform at the same time. Here, in addition principle, the actions cannot perform at the same time, but in multiplication principle, it must perform at the same time. So, if we cannot do the actions together, or the actions cannot happen together, it means that we are going to use addition principle. If the actions happens together, we are going to use multiplication principle. With the simple example, here Mary has different Barbie dolls and two different Cindy dolls. She wants to take them out to play with her friend. However, Mary's mother will only let Mary to choose one doll. In how many ways Mary can choose a doll? Now, three different Barbie dolls and plus two different Cindy dolls we have, so totally 5 different ways she can choose the dolls, because she is going to choose one doll only. Ways it's going to be. What about the second question? In the second question, Mary has 3 different Barbie dolls and 2 different Cindy dolls. She wants to take them out to play with her friend. Mary's mother will let her Mary to choose 2 dolls, one Barbie and one Cindy. In how many ways can Mary choose 2 dolls? Here, as you see, we are going to choose 2 different dolls. So, if there are 3 dolls and 2 Cindy dolls, 3 Barbie and 2 Cindy dolls, it means that 6 different ways she can choose. 6 different ways she can choose the dolls. And if I explain here why it is 6 different ways, if there are 3 Barbie dolls and if I name as Barbie 1 B1, Barbie 1, Barbie 1, Cindy 1, Barbie 1, Cindy 2. So 2 here. Barbie 2, Cindy 1, Barbie 3, Cindy 2, it's going to be. So she's choosing 2 dolls here. Here 2 dolls also, and here 2 dolls. And the last one is Barbie 3, Cindy 1, and Barbie 3, Cindy 2 is going to be. So there are totally 6, as you see here, there are 6 different ways to choose 2 different dolls. So we are going to multiply them, and the task, if it happens together, it means that we are going to multiply. Now in this question, Nicole has 4 different skirts, 3 different blouses and 2 pairs of shoes. So how many different ways she can dress for a meeting? If they ask, we are going to multiply all the possible cases here, because she's going to combine the suits here. I mean the skirts, blouses and shoes. She's going to combine them. She's going to wear them together. So 4 different way, 3 different way and 2 different way. These boxes we are going to use for the shirts, for the skirts, for the blouses and the shoes for the last one. And we are going to use these and the result is going to be 4 times 3 times 2, which is equal to 24 different ways she can dress. Okay. Now here we are going to solve 2 different questions. In the first question, there is a set, and we are going to write 2-digit numbers, and we are going to solve the question. Let's say if we have 2-digit numbers, and I'm going to show this box is like this is the first digit and this is the second digit. for the first digit, how many different number I can write? I can write 5 different number. And for the second digit, again I can write 5 different number because there are 5 numbers here. 1, 2, 3, 4, 5. Then I can write 5 different numbers here. The answer is going to be 5 times 5, which is equal to 25. Here, in the previous example, it says how many numbers can be formed if a digit cannot be used twice. This part is important. When we cannot use the digit twice, it means that when you use one of the digit here, second time you cannot write that one. That's why you should cancel one of them. So for the first digit, if you can use 5 different digits, for the second one, maximum you can use 4 because you have already used one of them. And the first digit and the second digit here, it's going to be like this, and 5 times 4, which is equal to 20, is going to be here in the set, if there are, let's say, 11, 12, 13, 14, 15, and 21, 22, it can be. But in the second set here, in the second set, we have 12, 13, 14, and 15, then 21, then 22 we don't have, and 23 is going to be 11, and 11 is not element in this set, or 22 is not element in this set, because it says that digit cannot be used twice. So as you see, 1 and 22, 11 and 22, 1 and 2, they use twice. That's why in the first question, without any rule, we can use that one, but we can use the numbers twice, but in the second one we cannot. Okay, how many 3-digit counting numbers there are? Now here the set is not given like in the previous one. We have to write the set. Firstly, by writing the 3-digit numbers, we are using this set. Seven, 8, and 9 is going to. Okay, we have written this set. By using this set, how many 3-digit numbers we can write? If we say, firstly we have to divide them into groups like this, and this is the first digit, second digit, and third digit place it's going to be. Here we have only problem. The first digit, it's going to be 9, the others, they are going to be 10 and 10, because here 0, which is 0 here, cannot be first digit. And if we have 10 number here, we can use 9 of them. The rest of them, 0 can be written here or here. That's why you can use 10 different number here, 10 different number. The answer, it's going to be 9 times 10 times 10, which is equal to 900 is going to be. Okay, with the next question, we have combination log here. In combination logs, you know, we are going to roll the the circles, and you're going to open the here locker, and in the combination log we have 5 different combinations here, and it says that if how many different combinations we can make if the second digit is 5. What does it mean? Second digit, we are not going to here there are 5 digits now. For this one you can write 10 different digits. For this one you can write 10 different digits, and for the last also can be written 10 different digits. Here the important part, it says that the last one is 1. the second digit is 5. That's why 1, it says 5, and here this one is only 5. There is one possible number digit for the second one. The rest of them, it should be 10. Another important part here, this is combination log, so it can start with 0. Combination logs can be start with 0. It is not 5-digit number. If it is 5-digit number, it cannot start with 0. Then we should say this is 9. Okay, the answer is 10 times 1 times 10 times 10 times 10, which is equal to 10 to the power of 4 is going to be. Okay, this question important a bit because here the logic is different in this question. What is the total number of positive factors of 600? When we ask, first we have to find the factors of 600. 600 divided by 2, it's equal to 300. Divided by 2, it's going to be 150. Divided by 2, it's going to be 150. 75 is going to be. Divided by 3, it's going to be 25. Divided by 5 is going to be 5. Divided by 5 is going to be 1. So here, when we get the 600 here, 600, it's going to be equal to, as a prime factor, 2 to the power of 3, 3 to the power of 1, and 5 to the power of 2, it must be. And all the factors of the 600 includes these numbers 2, 3, and 5 somehow. What I mean, if you want to divide, let's say any number divides the 600, let's say that is equal to 30. 30 divides 600, and it is equal to, normally it's equal to 2 times 3 times 5. So 2 to the power of 1, 3 to the power of 1, 5 to the power of 1. Or another number, let's say divides 150. 150 divides the 600, 2, 3, and it's going to be maybe 5 square. 5 square, and the maximum number can be 5 square. We cannot use also 5 cube here, which is let's say when it is 5 cube, it's going to be 5 cube. It's going to be 125, and 125 times 6 is going to be equal to 750. 750 also doesn't divide 600. Also, it is bigger than. And we have to be careful about this one also. So, or let's say 3 to the power of 2, which includes 3 to the power of 2. Let's write any number that with 3 to the power of 2. We are going to understand that it's not going to divide. Let's say 2 times 9, it's 18, times 5, it's going to be equal to 18 times 5 is going to be 90. 90, and 90 doesn't divide the 600. 90 doesn't divide the 600 because 60 divided by when we simplify, 60 divided by 9 is going to be here. This is going to be 20, and this is 3. So 20 is not divisible by 3. So we cannot use, in this question, we are understanding that one, we cannot use 3 square. I try to explain that one. We cannot use 3 square, so 2 times 3 square times 5, which is equal to 90. 90 doesn't divide 600. So the 3 cannot get the square or maximum value of 3. It can be equal to 3 to the power of 1 in the factor part I'm talking about. So you cannot use 3 squared as a factor. You can use 3 to the power of 1 and 3 to the power of 0. Now I'm going to explain that one also. Let's say 30 or here the 15 is also factor. 15 is also factor of 600, one of the factor of 600, but it has no 2 inside. But we know this one, 3 to the power of 1, 5 to the power of 1 we have here, and this is going to be 2 to the power of 0, which is equal to 1. So here at the end we are going to say like this: 600 factor of any 600, factor of 600 is going to be equal to 2 to the power of a times 3 to the power of b times here 5 to the power of c is going to be, here I forget to write a, and we can write here for the first 8 places we can write 4 different numbers. We can write 0, 1, 2 and 3. For this one we can write 0 and 1. Here there are totally 4 different numbers. Here 2 different numbers, and 0 I can write for this box, I can write 1 for this box, and 3 for this box, 2 for this box, and it's going to be 3 different number I can write. So the answer is 4 times 2 times 3, which is equal to 4 times 2 times 3, that makes 12 times 2, 24 different factors we can write. Again I am explaining this part: 2 to the power of a, 3 to the power of b, 5 to the power of c. A can get 4 different values, b can get 2 different values, it can get 3 different values. So all the factors should have 2, 3, 5 as a factor. So 2 to the power of, it starts with 2 to the power of 0, 2 to the power of 1, it starts with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3 is going to be. I think with this question we are going to understand better. Here if the factors are 3, 1 and 2, we are adding 1 to them, which is 0 also here, 1 to them, so 2 to the power of 4, 2 to the power, 3 to the power of 4 different number, 2 different number and 3 different number we can write. Now if I do this one for the 360, I'm going to divide them again. I'm going to divide them again here by using the prime factorization. Here it's going to be 360, and divide by 2 it's going to be 180, divide by 2 it's going to be 90, divide by 2 it's going to be 45. Now we cannot divide by 2, and I'm going to start with 3 divided by 45, it's going to be 15. Again 3 divides this number, and 3 divides and it becomes 5, 5 divides and it's equal to 1 is going to be. Okay, so 360 is equal to 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 1 is going to be, and the positive factors are going to be here this is 3 plus 1 times 2 plus 1 times 1 plus 1 is going to be, of course this is number of positive factors. It's going to be equal to 4 times 3 times 2, which is equal to 12. 24 is going to be again like 600.